Scientists in China are building world's largest underwater telescope known as TRIDENT. It will be placed 3.5 kilometers beneath the surface of the Pacific Ocean. You may be familiar with other large-scale scientific instruments like James Webb Space Telescope or Large Hadron Collider, and you may also know that none of them are placed under the sea. Then why TRIDENT is placed under the sea? The answer lies in the nature of the particles that TRIDENT is trying to detect. They are called the neutrinos. Every second, about 15 trillion neutrinos pass through our palm, yet we feel nothing. Neutrinos are nicknamed as ghost particles for this reason. As the world's largest neutrinos detector is unveiled by China, neutrinos has been a hot topic in news. So we could expect a question on neutrinos or TRIDENT for the upcoming prelims. UPSC have asked questions related to fundamental physics before. For example, in 2017, they asked about LISA project. In 2018, they asked about general theory of relativity. And in 2019, they have asked a question about detection of black holes. So, it is very likely that UPSC may frame a question on neutrinos in the coming prelims. For better understanding, we will divide this video into 3 sections. First, we need to know what neutrinos are on a basic level. Second, why we need to detect them. And third, why neutrino detection is so difficult. To cover this topic comprehensively, we have prepared a workbook on this topic. Please download the workbook from the link given in the description. We will start with the first section, that is, what are neutrinos? From hearing the term neutrinos, you may be confusing it with the more familiar term, that is neutrons. But it is important to understand that they are completely different. Neutrons are part of atom. We know that everything around us, including ourselves, is made of atoms. At the center of an atom, there is a nucleus, and inside the nucleus, you have protons and neutrons. Now, electrons are these tiny particles that orbit the nucleus. They are negatively charged, while the protons are positively charged. Neutrons are neutral, that is, there is no charge. So, in our universe, atoms are the basic building blocks. And when atoms come together, they can form the large structures and substances that make up the world around us. Neutrinos are not part of the atom like electrons, protons, and neutrons, but they are fundamental particles of universe. Neutrinos are solitary particles that do not combine with others to create large structures, as in case of atoms. They are like the lone wolves of the particle world. Unlike protons and electrons, neutrinos don't carry an electric charge. They are neutral, just like the neutrons. But they are much smaller and have a tiny bit of mass, so small that it was once thought they had none at all. Neutrinos are really special because they don't interact much with other particles. They can travel through the entire Earth without hitting anything because they don't react to the electromagnetic force that affects other particles like electrons and protons. This means they are very hard to catch and study, which is why the scientists have to build huge and very sensitive detectors, often deep underground, to find them. Neutrinos are also super abundant. Trillions of them are passing through you every second, coming from the sun, the Earth's atmosphere, and even from distant galaxies. There are 3 types of neutrinos, each linked to a partner particle: electron neutrons, muon neutrons, and tau neutrons. What's really interesting is that neutrinos can change from one type to another as they travel through space, a trick called neutrino oscillation. So now let us discuss why we need to study them. We need to study neutrinos because they are created in lots of important events and places, such as the sun, or in nuclear power plants during its nuclear reactions, or in cosmic explosions like supernova. Don't be afraid if you don't know what a supernova means. It is nothing but a huge explosion that happens at the end of a star's life. When a very big star runs out of nuclear fuel, its core collapses and then explodes with massive force. This explosion is called supernova. During the supernova explosion, more than 99% of the energy is emitted as neutrinos. So by studying neutrinos, scientists can get clues about things happening far away in space or deep inside stars that we can't see in any other way. Think of neutrinos like a secret message from space. Just like telescopes like Hubble or James Webb give us beautiful images of the universe by collecting light, neutrinos can tell us about the parts of the universe we can't see with light. They help us map out the cosmos in a whole new way. Also, neutrinos are key to testing our best ideas about how tiny particles behave and interact, which is what scientists call the Standard Model. The Standard Model of physics is like the rulebook for particles and forces at the smallest scale. You might have heard about the Einstein's theory of relativity, which tells us how big things like stars and galaxies move and interact. The Standard Model is our rulebook for the tiniest particles. When we study neutrinos, it's like checking if the rules in our rulebook are right or if we need to start writing a new one. So let us understand why is detecting neutrinos so difficult. We have already discussed that neutrinos don't interact with other particles that much, and they have negligible mass and zero charge. Just as ninjas move silently without leaving many signs of their passage, neutrinos travel through space almost undetected. Imagine trying to catch something that hardly ever interacts with the stuff around it. That's why regular detectors cannot catch them. But even ninjas leave some traces, right? Similarly, neutrinos also reveal their presence under certain conditions. When they pass through water or ice at high speeds, they sometimes collide with a molecule, and this collision can cause a tiny flash of light. Scientists use this little flash to figure out where the neutrino came from and what cosmic event sent it on its journey. So, to spot these tiny flashlights, scientists in China is putting TRIDENT instrument under the sea. And there is another huge one under the ice at the Antarctica. It is called Ice Cube Neutrino Observatory. These instruments are like big underwater or under ice cameras waiting for that tiny light. So before concluding, let's look what kind of questions can we expect from this topic. For prelims, we need to know the basic properties of neutrinos and the location of detectors such as TRIDENT in the Pacific Ocean and Ice Cube in Antarctica. For mains, a basic idea of neutrino research may be asked. In 2018, UPSC asked a question about Bose-Einstein statistics. Also, India's efforts in neutrino detection is another likely question. India has a neutrino observatory, the INO, being constructed under the Bodhi Hills in Theni in Tamil Nadu. To learn more about it and about neutrinos in general, make sure that you download Yoda IAS study packets. Link to download the workbook is given in the description. Remember that UPSC does not demand an in-depth knowledge of topics like this in mains or prelims. You should have a basic idea of what neutrinos are, how they are detected, and why they are important. So with this, we are concluding today's topic. See you in the next video. Take care and stay safe.